Oh wow, full house. Thank you guys for joining. This is To Be or Not To Be, breaking the IBM B2B Integrator with and without authentication. My name is Leo. I'm a senior security consultant at a company called WithSecure Consulting based in Manchester, UK, where I lead a service we have called attack path mapping. So most of the times you'll find me doing offensive security exercises, objective-based exercises, or purple teams, attack detection focused exercises. I've had the privilege to present at various security conferences around the world, including DEFCON Adversary Village, hence the Viking hat, RootCon, DEFCON, regional B-sides events, and that has been research from with regards to mobile security, to cloud and web applications. So overall, I would say I like my reverse engineering, and every now and then get to walk out with some CVs. So it was one application like that we were tasked to look at on behalf of one of our UK clients earlier last year. It was called Sterling B2B Integrator, deployed on a bunch of Linux servers. What ended up happening was we found some insecure configuration and decided to dig a little bit deeper to understand the true impact of that. And we discovered some command injection vulnerabilities, which actually led to a nice shell and even allowed us to elevate our privileges. Now, there's a plot twist here. If that configuration was secure, then there was another vulnerability, and this time it gave us RC, pre-auth RC. So wrapping up both of these things up, reported that to the client, to IBM, and eventually assigned a nice little CVE. This is what we'll be talking about today. We'll start with some introductions. What is this B2B integrator thing? What's CLA2? It's another important component, as we'll see. It's the one that we ended up exploiting. So we're going to zoom into that a little bit more, see in the demo of the exploitation, hopefully. And then we're going to talk a little bit about that plot twist, right? That change in plans. Following that, we're going to wrap it all up with the aftermath, right? The disclosure, some takeaways, and so on. Cool. Now, I don't know about you, but as with every other commercial solution out there, for me at least, it's just very difficult to understand what it actually does. You know, you go into all these documentation pages, you get all these product brochures, like, I don't want to buy it, man. Just trying to understand what it does. So yeah, according to ChatGPT, Sterling B2B Integrator is a commercial solution by IBM that allows businesses to exchange data and documents with their partners. Now, you might be wondering, what does that look like, in fact? It's got a web UI, nice fancy interface for administrators to do all their business sharing functionalities. That's, once again, it's a Java application, so it's deployed as a bunch of jars. And features include file transfer, job execution, EDI transactions, and BPML processing. Now, EDI, if you're curious, I know you all are curious, is electronic data interchange, and it's a family of standards for sharing data and documents. And BPML is business process modeling language, an XML-based language for describing business processes. Now, in this documentation, you'll also bump into the term Secure File Gateway, or SFG. I'm not entirely sure what it is. I'm not entirely sure what it does, but yeah, it's relevant, apparently. Now, CLA2, breaking that down, breaking the Sterling B2B Integrator down to its components. One of these components stuck out a little bit, like because of the name. Command Line Adapter 2, or CLA2, is a helper subsystem, according to the documentation, that allows you to execute command lines, as the name suggests. It's disabled by default, but our client had enabled that. It's a client-server application, and it's running on port 5052, but despite what that diagram has you think, the topology is inverse. So it's the server that initiates the connection to the client, and the client actually running the command. Yeah, keep this in mind, because otherwise you're going to get a bit confused later on. So, looking into the documentation of CLA2, I was looking into whether there are any security relevant configuration options, just to see if there was any vulnerability for our client. And I did in fact identify 3 such configuration options. Obviously the first one was which interfaces is the service bound to. Now, by default, that's supposed to be localhost only, and that was also the case for our client. So, you know, they were actually secure on that. Now, the second feature was SSL encryption that the solution supported for that client-server or server-client communications. Now, by default, that was disabled, and our client had also disabled that. So, obviously, that opens the window for a network interception attack, a person in the middle, but yeah, not too interesting. The last one, though, was authentication. And that solution also supported authenticating the server to the client. By default, that was enabled, but our client had disabled that. And you can see in the first screenshot how the main properties file had that enable authentication flag to true. Apparently, the solution supports override configuration files. So if you don't know about that, you'll be like, oh no, authentication is enabled. But if you look at the overrides file, you see that it's actually overridden and it's disabled. It's set to false. So pro tip, always check for any override files. So that was our plan, based on these values that we observed. Obviously, it's listening only on local hosts, so we're going to assume that we're a local user with a low privilege shell. Try and talk to that service, listening on port 5052, try and get it to run its intended functionality, execute commands effectively, and give us a shell, ideally. Potentially elevate privileges. It is a service after all. It could be running in an elevated context. Yeah, something like that. But I know what you're thinking. Cool story, bro. How do we actually do that? First thing I did was I gave it an nmap service scan just to see if that thing listening on port 5052 is something known, something we can find a known client for and just, make it easy for ourselves. That wasn't the case, unfortunately. Nmap did not identify it as a known service, but you'll see that it identified a response, which was a serialized Java object, which is kind of intriguing. You'll also see in this output that before all the class names and the property names, which is how usually serialized objects look like, you've got that result string in the beginning, which was a little bit weird. It's not the usual thing you see in a serialized object output. Anyway, we're going to leave that for now. And then I realized, we don't really need a third-party client. We don't really need anything ready because we have the client itself. And that meant that according to installation permissions, you could be able to get the jar files themselves and read them, decompile them. So in our case, these two files were word readable. I don't know exactly if that was intended, but this might be the case for you as well. So I loaded that to my favorite decompiler, JADEX in that case, very quickly located the main loop of that thread. There's not a lot of code going on. There's only a few Java classes. And so it was very easy to locate that very quickly. The main loop looks like that. So you've got some setting up initially, then there's a check for input, whatever that is, check for output, and then eventually run command, which sort of confirms our hypothesis here. Looking into that setup function, the primary, class which is relevant here is cmdline2params, or CLP, the CLP object. And you'll see over there in the circled element that there's a property in that object called cmdline, which looks like it's carrying our command line, of course. And into that run command, obviously in the beginning, the cmdline property is being accessed once again. There's some more processing going on. That's like to identify, break it down to arguments and tokenize it. And eventually, that's being fed into Java runtime exec. So we've got our full loop here. User input, cmdline carrying the command line, fed into Java runtime exec. Simple. So to try that theory, I was thinking of creating a Java exploit, a very, very simple client that would instantiate the cmdline2params object, set the property to the command line we want to execute, send it over to the socket, and profit. Now, obviously, to instantiate an object like that, you need to have the same class structure, and our POC needs to know what cmdline2params actually is. So I had to steal that from the decompilation, from the actual output of JADEX. I did that, send over the object, and this is what I got back. So it's similar to what we saw in the nmap output before. Now, you'll identify the first 4 bytes, ACED0005. If you're experienced with serialization, this is the magic byte sequence for a serialized object. And after that, once again, we see that result string, right, which looks a bit unexpected once again. So what is that object? I went down that rabbit hole trying to, whoops. I think our mic has gone off.
Yep. I will get a second mic.
Okay. Technical issues. Let's see. Are we good? Sounds like it.
We're good.
Thank you, tech support. All right, moving on. Yeah, we sent that object and we received back that one, that serialized object. So yeah, I was just saying that I went down this rabbit hole trying to understand what it is I'm looking at. So, did some experimentation, sent some object to the receiving end, parsed the output, cross-checked that with the source code, and this is what I came up with. This is my very, very simple, oversimplified version of the protocol. So remember, it's the server, like we said before, it's a server initiating the connection. I don't know why, but that's how it works. And it's sending that cmdline2params object with the cmdline property set. And then on the receiving end, you get a check for the input. And if that input within that object is being set, that field is true, then it's going to send back a signal. It's going to send back a string saying ready. Upon that reception, the server is supposed to send back a byte buffer. Then that byte buffer is being fed into a function called stream to disk. But regardless of that, regardless of the input, eventually it's going to execute that command line with the run function over there. And after that, it's going to send back that result string. And after this, after the result string, it's going to give you the result, which looks like it follows, it includes, what actually happened, the output maybe from the execution. Do we actually care about that? I know I didn't, because the only thing I cared about was whether my command actually executed. That was the primary objective here. Sure it did, and let me show you in a demo how it all works. Okay, let me bring over the video over to the other side. Oh no, I can't see it this way. So can you see the video? All good? Awesome. So what we've got here is we're simulating the server environment on the bottom half of the screen. I don't know if the font is big enough, but first thing we do is just run a PS just to confirm that CLA2 is actually running. We see that CLA2 client.jar, and of course the port 5052. The next thing we do is confirm the authentication. That's being set to false by the override file. So simulating the environment that we saw in our client. Again, main properties file showing authentication to be true. Override properties file showing authentication to be false. And before we leave the server side, we're going to start tailing the logs. The command that you probably missed was tail-f. And then on the attacker side of things, we're going to get that jar file, throw it into our favorite decompiler, because we want these two files. Remember, we want cmdline2params and cmdline2result for our POC, which is waiting for us on the right-hand side of the screen. So we decompile that. And then on the right-hand side, we've got the POC code, git cloned from GitHub, which I'll show you at the end of this talk. Within the decompilation, we locate the two files that we want, the two Java files that we want. Me typing very, very slowly. Imagine that taking place live. Wouldn't be so good. But yeah, we take cmdline2params, which is the object we're going to send, and then cmdline2result, which is the object we're going to receive. So we want to parse it and print out any variables within it, any properties. Now, having these two files, we're ready to compile our POC. There's not a very, very complicated process in the POC, and there's nothing very complex going on. But bear in mind that I'm going to use the JDK that was shipped as part of the B2B Integrator solution. And that was coming with a JDK as well, a JRE as well. So the reason I'm doing that is I want to have feature parity. I'm going to compile it with the same version of Java that was used for the client and it was used to run the client itself. Why? Just to make sure we have all the features there, all the configuration as well. And yeah, we use Java-C from that one, provide our Java files. So we should have a compiled POC now, so we're ready to give it a go. Once again, I'm going to use the Java from the installation, which also comes in handy if you don't have Java on your own system. So you're going to use the native Java version of the in the target server. Specify a class path. And then for the POC, which is the next argument, sorry, not for the POC, for the payload, which is our next argument, we're going to say bin sh, bin bash, ID, and then output this to just a file. So a very simple file write proof of concept. Next argument is going to be sent, the host and the port to send that object to. We see some debug output being printed, but importantly, the POC file has been created, and if we look at its contents, we see that indeed our service is running as root. So it looked like it executed. At this point, it's quite trivial to get a complete interactive reverse shell. So, you know, just a usual Python reverse shell from payloads, all the things or whatever, and you've got two files here. I'm going to start on this side of the screen, the listener, specify a port to listen to, and then on the other end, I'm going to do the same thing again, but this time I'm going to replace the payload command with one that calls Python. I did see Python installed on that server. It's very likely that you're going to have Python as well. It's a standard Red Hat Enterprise Linux server, according to the documentation. That's one of the systems recommended. And we're going to give it the path to our reverse shell, the port 1991, and once again the two other arguments, send, host, and port. Going to hit send, and voila, we've received our reverse shell on the other end. A very simple ID command should prove that. So that's how it worked end to end. Let me get back to my presentation here. Doesn't look right. All right. Now, this is how it looked like in our client's environment. Obviously, you can spot two differences immediately. The first one is that our service wasn't running as root. It was running as another user called SVC SFG. If you're wondering, I'm not entirely sure if that's recommended or not. Obviously, it's best practice. But I didn't manage to find it in the documentation as to what user Sterling B2B Integrator should be running as. The second observation, and a bit more interesting, is that this user is part of a group called domain users. And if that looks familiar, that's because indeed you can configure B2B Integrator with LDAP integration. So you can give it some credentials in the configuration file in plain text, and then it authenticates to an LDAP server, and it's running as an Active Directory service account, which means that if you exploit that, you also get a foothold into the domain to do your enumeration, lateral movement, and so on. But I haven't told you the whole truth. So if you remember the protocol before, I did say that that was a simplified version, and there's a few more things going on. So not much extra, it's just another condition over there. So beyond the check for input, there's also a check for output once the command has been executed. Now, if that check is true, it's also being fed into a function called stream from disk, and then regardless of that, it's going to send back, actually no, if the output is true, it's going to send back that byte buffer, right? What byte buffer? It's something that, yeah, I'm not entirely sure why. It was probably something received from disk. So, yeah, obviously, if we zoom into these functions a little bit, we realize that what we're looking at isn't just command execution. Obviously, this means that we've got user input being saved to disk, so arbitrary file write as well. We've got an arbitrary file being read from disk, which is also another possibility. And there wasn't any bounds checking. There wasn't any size checks on the byte buffer that the user would send. So what if I send a 1 terabyte object? What's going to happen? It's probably going to exhaust the disk. I didn't try that. But it should be quite straightforward once you get your command execution to rework the POC to do all of these things as well. Cool. You know, if you remember from the beginning, this all depends on authentication to be disabled. So we've got a very, very simple solution here. That's what our client did. They enabled authentication very swiftly, and they said, you know, give it another look. You know, do some retesting, look on this authentication feature, see if everything's fine now, and that's what I did. So I once again focused on CMD line 2 threads and zoomed into that area where authentication is being checked. You'll see the checked authentication, is authentication enabled, and looking into the actual implementation of that, It uses a Java key store. It's like a complicated key-based process. So yeah, it looked to be fine. Do you see anything problematic, though, in this code output? Anything vulnerable, maybe? I'm going to give you a hint. Just 3 lines above, if you zoom out a little bit, just 3 lines above, we've got this sequence, and I'm going to zoom out a little bit more. What we've got here is an input stream from which we read an object, and that object is then being cast to a Java class. So if you've seen insecure deserialization before, you can probably recognize that sequence. That's what this is here. We're looking at insecure deserialization. So it looks like we had some serialization-based issues, enabled authentication to get rid of them, but we ended up with more serialization issues. To confirm that hypothesis, I resorted to the good old YSO serial, de facto tool out there for testing insecure deserialization, and wrote just another very, very simple Python client to once again send the binary payload to the port. I did that, and this is what it looked like. On the top side of the command output, you'll see me creating that payload. I used the URL DNS for starters, just for verification. Provided my Burp collaborator URL, just to see if I'm going to get the ping back. Copied over both of these files, and then on the server side of the screen, I'm going to invoke my client, passing it the serialized object that I just created, or rather the YSO serial payload that I just created. Did it execute? Yes, it executed. I did get my ping back on my collaborator instance, which proves that there was insecure serialization there. Obviously, to make it a bit more impactful, someone would try to get complete RCE out of it. Unfortunately, that was not possible. I tried all the YSO serial payloads. I tried a few more ready-made payloads from other YSO serial versions. It looks like this wasn't possible, not because there were any defenses in place. It was more the case that there was no third-party libraries, actually 0 third-party libraries. And all of these gadgets, if you've seen YSO serial, depend on certain conditions to be there. But the code space here was so limited that you would need a custom gadget. This could be possible, but unfortunately, I didn't have enough time to create the custom gadget. So an exercise for the reader. Time was up, eventually. By the way, sorry, you can see on the right-hand side the shell script that invokes the CMD line 2 server. And you'll see on line 51, where the Java command is being executed, that there's no class path parameter, which just proves that there isn't any third-party, there aren't any third-party libraries involved in there that we could potentially exploit for gadgets. So, since time was up, I had to wrap it all up, and yeah, start the long and patient disclosure process. Obviously, we disclosed both of these issues to the clients, and with their permission, reached out to IBM via HackerOne, where they had their vulnerability disclosure program. I would say that overall that was a positive experience, albeit lengthy, but a good interaction overall. I named these issues as, the first one I called it arbitrary command execution, and that was very, very quickly turned down as informative, given the fact that you need authentication to be enabled, and we don't recommend that, to be disabled, and we don't recommend that, so not an issue. Fair play. That was very quickly turned down to 5 days, but for the other one, the insecure deserialization one, we had to wait. And when I say wait, I mean something like 6 months. And eventually that one was patched. It was, of course, identified as a vulnerability. A CV was assigned, risk rated 8.8, and for the first time, I get to see the versions that were affected, which I had not seen before. So, before we go, just a couple of takeaways. If you're an attacker, next time you face an unpatched version of the Sterling B2B Integrator, you're going to have this dilemma, right? To auth or not to auth. If authentication is disabled, you're going to have arbitrary command execution, potentially a privilege escalation vulnerability. But if authentication is enabled and the version is unpatched, of course, you can get your insecure deserialization, get some RC if you manage to find a custom gadget. If you're a developer, this should not come as a surprise. The rule of thumb here is don't deserialize untrusted input. This isn't something new. It's been something we've been saying for years now. There are many, many ways to prevent that, to mitigate that. In that case in particular, for B2B Integrator, one solution was to do that authentication check before deserializing the input. That would have prevented all of that. A good practice would also be to replace the whole protocol, the whole transport protocol, and instead of exchanging Java messages to switch to a database protocol, exchanging maybe JSON messages, protobuf messages, even binary, whatever you want, as long as it's not Java serialized objects. And I'm mentioning these solutions because I'm not entirely sure what they did. I have absolutely no idea. They weren't keen to share what the implementation was, but so, hey. But generally speaking, outside of that context, some solutions to prevent insecure deserialization is to override the resolve class method of the native object input stream class and implement some allow listing in there, which classes should be deserialized, which ones should not. Alternatively, you could introduce a security manager, define a policy that says basically what permissions your classes should have. Or if you're targeting a Java version above 9, then you could potentially use another nifty feature called object input filter, which allows you to do checks like these, checks like that on runtime based on conditions. The only reference I want you to remember, the single source of truth, the Bible when it comes to insecure deserialization is the OWASP deserialization cheat sheet. Everything's in there. You'll find in there mitigations. You'll find their exploitation details for all your languages. So yeah, remember that pointer. Before I GTFO, here's your POC code. I've uploaded that to GitHub. It should be public now. And that's all from me. You can find me on Twitter if you want to discuss further. Thank you very much for your time.